All right. Hello, hello, cool cats and kittens. This is Miss Gallant with Unit 2B review. We are on activity 13. This is the last activity in Unit 2. So this is my last video for a little bit. We'll go ahead and jump right in with some vocabulary review. And we're making equations from a data set. Basically, this is scatter plots. So the vocab review we have some, basically just some different correlations. So a correlation is a relationship between two variables, or seeing that whether or not one variable has an effect on another variable. So if we look, these are some different examples of correlation. So the first is a linear positive correlation. And you can tell it's not a straight line, but like you could draw a line through it and it would model the data pretty well. It's obviously not curved. It's not a sharp curve like a exponential or quadratic. It looks fairly linear, it's not perfect, but it looks fairly linear. And it's going in a positive direction. It's increasing from left to right. All right, the second one is decreasing from left to right, and again, it's fairly linear. This one looks a lot straighter than the last one, so I would say this is a stronger correlation than this one. This is a weak linear correlation, so it's positive. It looks fairly like a line, but it's not nice and neat like these two. This is a little more spread out. And then we get to an example of no correlation, where there is no way, if I asked everybody in my class to draw a line of best fit, I would have some draw this line, some draw this line, some draw this line. It's really, there's not a linear pattern to it. It's just kind of scattered data all over the place. Okay. So then what we're looking for is whether or not there is a causation between two variables. Does one variable cause the other variable to change? So there might be a relationship between the two variables, but that doesn't mean that one is causing the other. It could, but it doesn't necessarily mean that. So an example of a causation is, if I see that someone's doing more exercise, I should also see that they're burning more calories. I have some great examples of where correlation and causation do not mix. But that's for another time. Okay, so, oops, got all my wires crossed here. So let's just jump into the practice. So we have an owner of a cafe kept records on the daily high temperature and the number of hot apple ciders sold on that day. That sounds good, except it's starting to get too hot here for that. Okay, so the data is recorded low. So he looked at the daily high temperature and how many apple ciders he sold that day. So, that's our data. So we're going to create a scatter plot first. And let's see. I range from 15 to 80 on my temperature. So, let's see. Let's go by maybe 10s. So this will be 20, 40, 60. I don't like that. So let's go by 15s. So 15, 30, 45, 60, 75, 90. That looks good. So we went by 15s instead of 20s. Okay. And then, let's see, I go from 12 to 70, so let's 20, 30, 40, 50, 60, 70. Okay, so we'll go by 10s. Well, by 5s. 10, 20, 30, 40, 50, 60, 70. Okay, so this is one, it's not going to graph pretty. Oh, and let's label. We'll do high temp. So the high temperature of the day, and this is, This is the number of apple ciders sold. Okay, so let's start plotting some data. So at 30, when the weather was 32 degrees, we sold 51. So that's going to be a little over the 30, do a little over the 50, so about there. So these are not going to be perfect on the crosshairs. There's not really a way to do that and label your graphs nicely and correctly. So, and that's okay. It doesn't have to necessarily be on the crosshair. Okay, when the temperature was 75, we only sold 22. So 10, 20, 2. Okay, when it was 80, so that would be about here, we sold 12. Okay, when it was 48, we sold about 40, yeah, right there. Wait. 48, yeah, okay, I had to double check. I got my 40 and 48 mixed up, which one was which. And then when it was 15 degrees out, we sold 70 apple ciders. Okay, so again, it's not a perfect pretty line, it's just data. So it asks, is there a correlation between variables? If so, what type? So I would say that this is pretty linear. And it's a pretty strong linear. I mean, it's not perfect. It's not a perfect line, but it's a strong linear. It's not very weak. I mean, it's not all over the place. So it's a strong linear, and it's negative because as we go from left to right, our data decreases. So it's a linear, strong, negative, or negative, strong, linear. Okay. Oh, and yes, there is a correlation. I answered those questions backwards. Okay. So, C, determine the equation of the line of best fit. So first off, we need a line of best fit. So what we can do, there's a lot of ways to do this. We could draw it, but honestly, I don't want to do that. So I'm going to use Desmos on my phone. Let me get out of, let's see, I've locked it down for screen time. It's after 10 o'clock, so let me find Desmos. That would be, oh, under here? Yeah, here we go. Okay, so we're going to ignore my time limit for today. Okay, so what we're going to do is we're going to put a table in for Desmos. Let's see if we can maybe see this better. Let's see, maybe if I turn my light off or turn my exposure down. There we go. Perfect. So I'll turn my exposure back up in a little bit. So we're going to take our data from our table and make it a table in Desmos. So we're going to do 32, 75, 80, 48, and 15. Then we're going to come back over here. And our Y's are 51, 22, 12, 40, and 70. Okay, and just so you know, on the EOC, you have access to Desmos. Now, obviously, you're not going to have it on your phone. You'll have it on your computer screen. But the Desmos Graphing Calculator is the official graphing calculator of the EOC. It sounds like an NFL sponsor when you say it that way. So we have our data graph, or our data graphed on here. You can't see it. So what we're going to do is we're going to change our x-axis. We're going to go from 0 to 90, because that's what I did on this graph. We went from 0 to 90. And then we're going to go from 0 to 75. Just want to make sure I have some extra room at the top so you can actually see it. Actually, let's go from 0 to 80. Okay. And you can see our data, which is pretty close to what I have. I'm sure this is, well, I know this is a lot more accurate than me doing it by hand. Alright, so I want the line of best fit, or I want the regression line. So in Desmos, again, if I were to do this by hand, I would draw a line through the data, and then pick 2 crosshairs, and then start calculating slope and y-intercept. But you can use Desmos on the EOC, so why not? So what we're going to do is we're going to do y1, and I'm trying to find it on here. I want the regression line. I don't want functions. Let's see, let's try this. Okay, y1 regressed against m times x1 let's see, where's my plus button? Oh, plus b. And so we're given this line. And if you look, they give us our m and they give us our b. So I'm going to write that over here. Y equals, we're going to round to the nearest hundredth, so negative 0.82 x plus, we're going to take our b, 80.2281. Wait, 22. We'll round that to the nearest hundred, that'd be 23. Okay. Let me turn my exposure back up so we can see the actual paper. We'll move this away from now. Okay. So, we have the, what is the slope? So my slope is negative 0.82. And what that represents is that for every 1 degree that our temperature increases, we sell 0.82 less apple ciders. I know that sounds really, really weird. So what let's see, let's write it like how many apple cider sales we decrease by as the temp increases. Okay, so this is identify the y-intercept. Okay, so that would be the 80.23. And what does that y-intercept represent? Well, that would be when the high temperature is 0 degrees. So theoretically, we'd sell roughly 80 apple ciders if the temp is 0 degrees Fahrenheit. It's kind of hard to read, but it is what it is. Okay, so F says use your model to predict the number of hot apple ciders the cafe would sell on a day when the high temperature is 92. So when it's 92, it's not going to be a lot. It's not going to be very many. So what we're going to do, oops, we're going to go back to Desmos. Let me turn my exposure down again so you can see the graph. And I'm going to go here and actually just touch my thing until we get, oh, you can't see. Let's see. Now I don't want to keep this up. Probably as low as I can get it. So we're going to move this down to where we see 92 degrees. Oh. And at 92, it's 4.368. Okay, what you can also do is take the 92 degrees and plug it in for x here and solve. Which is probably what the question was asking us to do, but when you have, oops, let me put the exposure up. But when you have Desmos, you can do that as well. Okay, so we would sell probably about 4 apple ciders. When we explain, our explanation, we could use our equation. So yeah, let's do that. So y equals negative 0.82 times 92 plus 80.23, and that's going to equal 4.368, which rounds to 4. It's too hot for a hot drink. Okay. All right. So let's move on to page 2, because it's starting to get to be a lengthy video. So we're going on to page 2. Page 2. All right. So we have online shopping has experienced tremendous growth since the year 2000. One way to measure growth is to track the average number of daily hits at the websites of the online stores. And then we have so we have 3 different stores, and we have their store records or their site hits. And so and these are years since 2000, years since the year 2000, and then how many hits they've received. Okay. All right, so we want to compare and contrast the growth of the 3 online stores. So if we look at Nile River Retail, it's increasing pretty slowly. It's got a slow, Nile has a slow increase. Let's see, how much is it increasing by? Let's see, let me get my regular calculator. So we have 68 minus 64.1 is 3.9. 64.1 minus 60 is 4.1. 60 minus 56.2 is 3.8. So these are all really, really close. And it's, again, 4.1. So it's a slow increase. It's pretty steady. So every 2 years it increases by close to the same number. Let's look at eBay. And this is a more rapid increase. This increased by 3.9. And then 17.2 minus 4.9 is 12.3. 37.2 minus 17.2. Oh, that's an increase of 20. And then this would be a 27.7 increase. So it's increasing But not only that, but how much it's increasing by increases. It's increasing by about 7 or 8 between each increase. So there's not really a common like this isn't a common difference, but it's pretty close. This isn't close, but how much it's increasing by increases pretty closely. Alright, and then let's look at Spendco. And this is super, super rapid. Okay. So let's look at the increase here. This is increasing by 4.6. And then, let's see, 20.9 minus 6.6. That increases by 14.3. 68.1 minus 20.9 is 47.2. And then we jump all the way up to 220.4 minus 68.1. That's a 152.3 increase. That's a huge increase. So this might have a common ratio. I might be able to multiply to get to the next number. And that actually makes sense because times about 3 would get me to 6 something, times about 3 would get me over 18, times about 3 would get me over 60. So yeah, that makes a lot of sense. So this is more of a multiplication. It's more of a multiplication increase. Okay. Alright, so let's take that and let's graph our data. So at year 0, we have, on Nile, we have 52.1. At year 2, we have 56.2. At year 4, we have 60. At year 5, we have 64.1. I might have made these a little too close. And at year 8, we have 68.4. So this is more like this. Didn't really graph those points as well as I could have, but you know, you live and you learn. Okay, eBuy. At year 0, we had 1. Just 1. At year 2, we had 4.9. At year 4, we had 17.2. At year 6, we had 37.2. And at year 8, we had 64.9. Okay, and then at Spendco, at year 0, we had 2. At year 2, we had 6.6. At year 4, we had 20.9. At year 6, we had 68.1. And then at year 8, we jumped all the way up to 220.4. Alright. Okay, so C, which online store's growth could be modeled best by a linear function? Which one can be modeled by a quadratic and which one by an exponential? Explain. Okay, so Nile is going to be modeled by a linear function. The increase every year or every 2 years was nearly constant. Okay. E by would be the quadratic. And that would be because the increase of the increases was nearly constant. So it didn't have a common difference, or the differences weren't constant, but the difference between the difference, or the second differences, were nearly constant. Okay. Also, if you look at your data, 2 squared is 4, 4 squared is 16, 6 squared is 36. So these are nearly a little bit off from squareds. Okay. And then last one, SPINCO. Would be the exponential. And it increases by almost triple. So this one doesn't increase, like I don't add, I multiply, I triple it to increase. Or I know I put each year, but it's every 2 years. Okay, and then let's see, and then that is it for the guided practice on activity 13. As always, if anybody has any questions, feel free to email me. I'm more than happy to explain, or email whoever your teacher is, and they should be more than happy to explain. You guys stay healthy, stay safe, keep your distance away from each other, and yeah, so I hope you guys have a good rest of your day. Thank you so much for your attention. Bye.